In this video, I'd just like to give you some intuition as to how to decide when two things are isomorphic or not, and then what the isomorphism or the function from the vertex set for G to the vertex set for H that is one-to-one and onto would be. So first, looking at these two graphs G and H here, these are isomorphic graphs. Now the way to get to see that, and the intuition for this is, now look at H over here. Right, now think about picking up H and unwinding him. So you take U1 down and move him over, move U4 over, and then pull it straight, and then it will look just like G. So the idea is if you can take H, pick up H off the page and move the vertices around a little bit, shorten or lengthen the edges some, and then set it down on G, then they're isomorphic. All right, so let me show you what I mean by that. All right. Notice that you could take U1. So what I'm going to do is I'm going to take U1 and I'll pull them over here. And I'm going to take U4 and put it up right there. So what that would do is that would make this look like that. So let's see, that was U3 there, U2, U4, U1. And so these two here, these are the same graph. And then notice what you could do. Now if we move this thing over here a little bit, put them right here like this. U3, U2, U4, U1. Then that tells me what my function, what my one-to-one and onto function from the vertices of G to the vertices of H need to be. So I'll put here vertices of G, and over here I'll put vertices of H. Let's see, we got V1, V2, V3, V4. Here I've got U1, U2, U3, U4. Okay, and so now you can see V1 would go to U3. V2 would go to U2. V3 would go to U4. And V4 would go to U1. And now if we were to make this into a table, let's see, we'd have V1, V2, V3, V4. Let's see, V1 went to U3, V2 went to U2, V3 went to U4, V4 went to U1. And now first of all, the only way we can tell from a table, just by looking at it, if it's a function, one-to-one, onto, is if you fill out all of the cells of the table. You fill out all the information on the table. So we've done that because we have V1, V2, V3, and V4 listed there. Okay, so now these are all different, right? So that means it's a function. These are all different. It's one-to-one. And there's no D and E's in any of these spots here, so we know that it's onto. So our function is one-to-one and onto. Now, how do we know it preserves edges? Well, that's where the intuition comes in. In the next series of videos, we'll see a way to check if our intuition is correct. But right now, we can just tell because these two graphs are small, only 4 vertices and 3 edges each, we can tell that the edge relationships are preserved. And that's the intuition.